Good morning, everybody. My name's Jason Fox. I'm the Senior Technical Evangelist at the FIWARE Foundation, and subject of today's Wednesday webinar is customizing IoT agents. So let's get down to the show. We're going to be covering a lot of ground here. There's a lot of going to be staring at code, but we're going to start off by just having an overview of the existing IoT agents. If you're going to build your own IoT agent, you don't need to build it from scratch most of the time. Usually you can get ideas and a large chunk of the code, a large chunk of the framework from an existing IoT agent. So we're going to go through, walking through three different levels of custom IoT agent. Now, the simplest one is just to take something like the IoT agent for Ultralight or the IoT agent for Jason and just modify the payload a little bit. Now, in this case, we're just going to change the payload from which is a text-based pipe delimited syntax, which is Ultralight, into something like XML, which again is well formatted. You know what the rules are. You can tell whether this is real XML or not. And within any IoT agent, you've got to consider three elements. You've got to consider the payloads, the transports, the protocols, and we'll go through some of those. Having done that, then obviously, if life was that simple, then you wouldn't need a webinar like this. So we'll have another look at a much more complex XML-based IoT agent, which is an IoT agent for the Adapt ISOXML protocol, which is used in agricultural machinery. This comes with approximately 200-page specification, and you can see that that's going to mean that we're going to have to do more processing in order to get the data to flow properly. Finally, we'll look at something which is a little bit different, which is a file-based device measures. This is what you'd need when you have a gateway style data. In this particular case, it's loading up water data, but it's doing it in a batched system. And again, it's using a custom payload. In fact, two custom payloads. It's got a CSV and it's got an Excel file. The existing IoT agents, you can see the ones which are in the FIWARE catalog. We've got a variety of custom standard IoT agents, and they can basically be divided into two types. You've got those which are really low level, where the payload is, say, binary bits like Sigfox or LoRaWAN, which is using constrained devices. And you've got those which have got a higher level payload, a payload you can read, basically, which tend to be done over either HTTP or MQTT. MQTT takes the same role as the LoRa gateway, basically. It's a message broker. It's passing information around. In theory, you could be using HTTP for this, and indeed, within my own firewall, I would probably use HTTP communications. However, when you are talking about getting stuff from devices in the field, it's probably going to be either MQTT or MPQ or whatever. Now, you can see on the left, you've got these which are character-based or JSON-based or plain text-based. This is a lot easier to parse. It's a lot easier to see what's going wrong, and you can just actually see how data is coming into the system. Now, just because I've got this list of 6, you just saw what the Adapt ISOXML one, the previous slide, doesn't mean that that's all that's there. It could be the case that there are actually already custom proprietary agents on the FIWARE marketplace, which is, if you are a company selling a device and it's FIWARE ready, you might want to do that through your own IoT agent. So don't think that you have to start from scratch. Don't think that the catalog is the only place to look for these IoT agents. Look on the marketplace as well, because that will potentially have other IoT agents on top of it. Most of these IoT agents on screen at the moment are usually node-based, but within the FIWARE marketplace, for example, I've seen ones which are, say, C# based, because they're just fiddling around with a bit of data, they're doing a bit of an upsert, and that's it. That's all they need to do. It's work which doesn't need to be done on the device. It doesn't need to be done on the edge. It can be done on the on the cloud through an IoT agent. Let's consider transport, payload, and protocol handshake. This is the fundamental of whether you want an IoT agent and how it works. Now, you may be constrained by how the standard protocol works, like in the ISOXML adapt, but you may have flexibility on deciding what your payload can be. If you've got any flexibility in what your payload could be, I would highly recommend you go for either ultralight or JSON, because that way you can most easily modify your data. Obviously, NGSI is a JSON-based format, so it's a lot easier to transform an arbitrary JSON payload into a well-formed JSON payload. Now, in this particular case, I'm saying I want an IoT agent listening over HTTP. Why? Because it's simpler. It just makes my tutorial simpler. But this again is fundamental to how your architecture will work. If you have power issues, if you have a broad network, if you have an unreliable network, you may be looking at other transport mechanisms, which is the south port of your IoT agent. This is important because when we get into bindings, you'll see that there are different options for how to connect X, Y, and Z. Second thing, when a message is received at an IoT agent, you want to make sure that it's not rubbish. Obvious thing to do there, if you're talking about HTTP, check the content type. You know, if I have an XML based IoT agent and you're sending me a text CSV file, I want to get rid of it straight away. It shouldn't go into my system. So you can do some sanity checks on the payload before you even start parsing the payload. You want to be able to reject things and reject things fast. Now, I want an IoT agent that rejects payloads missing an API key. If you look at the JSON or ultralight IoT agent, they set up their service groups with something called an API key, which again is passed as part of the message. It's usually a parameter on the HTTP post request. And this means that I can say, okay, this particular payload is related to my motion sensor or what have you, or this is one which I don't understand. You don't want an IoT agent to be spending too much time dealing with rubbish. You want to get rid of the rubbish really quickly. Now, you may, and an awful lot of systems are just reading in measures from devices, you may just want to have an upsert, which is very, very simple. But if you want to process both measures and commands, commands are at the moment a lot more tricky to deal with than measures. Measures is quite simple. Data comes in from into the south port. It is processed into an NGSI request, either V2 or LD, and it's pushed into a context broker. Great. However, for commands, it's a bit different because at the moment, commands through IoT agents are based through registrations, which is all done automatically under the hood for you anyway. This is the reason why you want to have an IoT agent, because you can use all the common stuff from the IoT agent node lib. And this will then be flagged context broker saying, hey, I can't deal with this attribute, but I know someone who can, and I'll pass this information on to the IoT agent. And the IoT agent will then say, okay, now I've got the command, I must do something, but my actuation is likely to be asynchronous. So therefore, all I can do is to send out the command onto, say, my MQTT network, and then wait. I can say that I'm in progress, but that's fine. And I want the device to respond saying, yes, I've successfully completed your service or whatever. So with commands, not only do I need to take in an input value from the south port, I also need to be able to take in success and fail values from a actuation attempt. So let's have a look at a dummy, simple IoT agent in detail. This covers all of those questions on the previous slide, saying what's actually happening. So now, my content type, I'm XML. So funnily enough, I would use a content type header of application/XML. What would you expect? And you can see a measure. This is just using switching on a device value of C, whatever, or I could have a robot which is doing a left turn or whatever. You can see it's a well structured payload in each case. Now, this may well be supplied by the manufacturer or protocol you're actually using, as I said, ISOXML adapt, 200 pages long, or it may be something you have the flexibility to do yourself. Now, you just need to, in order to deal with this, you just need to add common middleware functions to the IoT agent. There are a load of access points within the IoT agent node lib, and you just need to put the code into the middle. So northbound, you just need to say, okay, I somehow receive my data. I need to take it from the request and get it into memory so I could then massage it and create the necessary attribute value data objects, which is just a pair attribute X value Y, attribute X value Y, which is then processed later by the IoT agent itself. And then just push it up using the update function. That's the one which does all the NGSI v2 or NGSI LD stuff, so you don't need to worry about it. Southbound, very similar. We just need to put stuff into set command handler saying, yes, I need to go off and do stuff. Let's have a look at some code in detail. So I have a custom IoT agent here, and I built it from a Docker context. But as you can see, it's got all the usual stuff you would expect for any IoT agent talking to the context broker. It needs to have ports open because I'm going to be dealing with XML. It needs to know where the context broker is, and it's got some standard values which are saying, okay, I'm V2, I want to have verbose debug, and so on and so forth. You can use the debug when you are creating your own IoT agent to work out where it's going wrong, because it will crash all the time. Obviously, if you try and send ultralight data into my XML thing, it won't work, and so on and so forth. So we've now got the thing up and running. This is the XML agent. As usual, first sanity check is, do we actually have anything out there? And it says, yes, I am there. I can create a service. In the usual manner, I've got a random API key with, and I'm saying I'm going to this context broker. Once again, we've got 201 created. I can provision a specific sensor. This is another reason why you use IoT agents, in that you can have a standard way of mapping your stuff. This is using the standard API to say, yeah, C is count inside or I want the static attribute, or I want a link attribute, or whatever. Again, it goes in there and creates it. Now, when I do the dummy measurement, you can see, in this case, I'm actually talking down to an endpoint called IoT XML, and I've got some lump of XML in the system, and I've got the right header. So I should be able to set my motion sensor to 3. And if we read from the context broker, you can see that I have got a motion sensor which has got an appropriate mapping. I've called it NGSI D rather than LD. But you can see that it's got a count value, which is now 3, and it's all automatically put in the timestamp. Obviously, if I was using NGSI LD, it would be using the observed at rather than the metadata timestamp instant, but it does all that stuff for you. So I could say, right, that's it. That's all you need to do. Well, it's a bit a bit more in depth in that. We've got to work out what's actually going on. So the first thing to look at is I've got to somehow read in XML in this particular case. I need to get it from the request into a fashion I can deal with. I'm dealing with Node. I want to have this as JSON objects. So I'm just going to search on the internet, find an appropriate parser, and then make sure that that is actually used as part of my my binding. If I look for this, you'll find that whenever I'm getting a GET request, I want to do this. I then do a series of standard functions. Now, the naming convention on JSON and ultralight is precisely the same. They're basically two evil twins, and they go through parsed data, add timestamps, handle incoming measure, etc., etc. I would heartily recommend that you, within your own custom IoT agents, follow the same naming convention, because it's easier to work out what's going wrong. So, okay, I need to get hold of my data. I need to somehow parse the data to get hold of what's in there, and I need to be able to deal with it. Where within this code base, which is actually one of the FIWARE tutorials, various amended functions have been highlighted using amended function. So first thing I would do, as I said, sanity check. Having managed to attempt to get hold of some data, the parser will load a null if it's not proper XML, or it will reject it directly, so that's fine. So we know that this is going to be valid XML. I can do things like check for my header. Is it application XML? Is it valid? Similarly, I can check for have I got the device key. If you go back to here, you can see that the key is whatever within the payload. Having checked the mandatory functions, the next thing is that we'll say, okay, we've got something. What are we going to do with it? And in that case, we go into the parse data function. Now, all of these do follow the same paradigm, in that we have some data, and assuming we've got a payload, it will go into a parser. Now, this will obviously depend on how your data is actually structured, what you want to do. In this particular case, we go into here, and you can see I'm doing some stuff here, and I'm manipulating it from that XML format, which is and I'm putting it into a series of JSON objects. It's an array of JSON objects, each with a key and a value. Now, this is the standard which the IoT agent will actually grab hold of, and therefore it will work fine. I would do a similar job if I was doing a command. I think this one here. So in the check manage parameters, startup. Got one previous. Oh, sorry, wrong one. Yeah. So I'd be similar thing if I'm doing the command, in that if I'm retrieving data which is in the format of yes, it's success or whatever, I can then say yes, I'm reading this value. I can then update the actuator with the response. Okay, so that was a simple example. Let's move on to something a little bit more difficult. ISO 11783 is a ISO standard. It's electronics communication protocol for agricultural equipment. As I said, it's a very long specification, and you can see the payloads are much more verbose than that simple XML, but you can use the same sort of method to attack this information. If you look at the data on the right, it's actually readable by humans. If you have the specification to hand, you can see that my farm is called Manor Farm. The customer is called Mr. Jones, and I am putting the task, what I'm going to do, which is obviously the context data, is I'm going to put a herbicide onto my potato crop, and I have a timestamp saying this is when it actually happened, and you've got other bits and pieces. Now, this means that we know what the payload type is. We know what the structure of the data. So let's see if we can actually load up some of this information. This is another IoT agent. Again, if I just bring up the IoT agent for XML. Again, adapt ISOXML protocol. You can see once again you've got the same standard sort of environment variables. It's reusing what you would expect. It's got a fixed version of the agent. Obviously, I'd use latest if I was developing it, but I want to show this off, or I could use the a Docker file inside it. The Docker file, for what it is a fairly standard multi-stage build for a node application. It's getting hold of the information as you would expect. So we're still, there we go, loading up some context data, and it started. Okay. Once again, the first thing to do whenever you do this is to do your quick sanity check. Do I exist? And you can say, yes, I've got the node lib, and you can see that the version number of my application matches what I had in my Docker file, which is good news. Now, usually you'd go create a service group, provision a sensor. However, in this case, if I just create a service group, I don't need to provision a sensor because I've placed this all in my config. So I can actually send a message which has got 2 customers and a farm in it. This is Animal Farm, so I've got Napoleon the pig. I can send that up there, and you can see it's saying, okay, that's not bad, not a problem. And I'll get back the information from the context broker by here, and you can see that with all my entities, I've got person types, and I've got building types. And you've got the URNs, and they match properly. So I've managed to parse my data and get the information coming out. Now, this one is a little bit more complex because obviously you don't know what the format of the NGSI payload should be, because it will depend on which attributes the user will want to extract. So that needs to be customizable. So we need to be very careful here as to how we're getting hold of the information and how we're passing it through the system. Get that a bit bigger. Now, the way we do this is that there is a way you can manipulate your data after you've sent it to the IoT Agent library. There is, if you have a plugin, you can interrupt the information going from the update function and before it gets sent to the context broker. This is how timestamps work. There's a standard timestamp plugin, and that will allow you to manipulate your stuff. Now, what I have here is an adapter which is loading a load of custom data manipulators on the fly, so that when I actually load my data, I'm going through my parser, I'm just throwing in all my data directly. However, because I'm actually using a custom parser, I then I think it's this one, isn't it? Yeah. Within my parse data, I can get hold of the ISOXML. This is very similar to the XML version. Again, check my mandatory parameters. Have I got what's expected? Am I missing stuff? All the standard stuff. However, within the adapter is offering a load of contact points, and this is transforming our data. So if I have a farm, which was the data I had, where was it? Send a farm. So if I've got a farm, I know I've got these attributes. I might want to map farms to a standard building model rather than a farm. It might be an agri-farm model. I don't care. Don't really care what the data model is. But what I'm saying here is, okay, I know I've got the attributes. I've got name is in attribute B and address is here, and I need to modify that as necessary, and relationships are done as so on and so forth. So I can then transform my data using my plugin in order to get the manipulate the data as necessary. Obviously, all this code is available online, and you can go to much more detail. But let's move on to a third option. Custom IoT agent for CSV and Excel. Now, there comes a point where there is no point in trying to create a common IoT agent. You can see from the adapt agent that it's flexible enough because you can change the code which you come into the plugin so that it will work for multiple customers. For the XML one, again, because you're using the standard data mapping, which is used in your provisioning, it's going to help be able to call this attribute X, this attribute Y, whatever. That's not a problem. However, at some point you will come across a legacy or a proprietary format where you are not in control of the data that the customer is providing. In this particular case, the customer says, okay, I'm going to give you a CSV file. I'm going to give you an Excel spreadsheet. You have to deal with it. Now, provided you are dealing with measures, this is actually relatively simple because parsers exist. And you don't have to write this in Node. You could write this in whichever programming language you've got. It's just that it's easier to show the same programming language within one webinar. The data is always, and this is perhaps should be stressed, in proprietary format. What you need to get a specification, it could just be a note on the back of an envelope. What do the columns mean? What does the data mean? Which bit of data goes where? As it happens here, you can see there's the first column in my CSV is a timestamp, and that is going to be my observed date. I'm doing a batch update here, but without some sort of communications with my customer, I haven't a clue what this data is. I don't know how this data works. Haven't got any idea what's going to happen. Now, the process, how fortunately, is common. So it doesn't matter what your payload is, you're going to have to go through these steps. Sanity checks on data input. In this particular case, is it a text file? Is it a CSV file? Is it the right format? You upload the raw data file somewhere because I'm using a file-based system. I don't want to be able to read it. And unless I've got a copy, I can obviously destroy it later. Unless I've got a copy, it's just not going to work. I can read in raw data rows from the file. Somehow I've got to get my file into an in-memory object. And it doesn't, again, at this point, it doesn't matter what the format of that object is. It's just so I can deal with it. If you're talking about a massive file, you might need to use some sort of streaming techniques, for example. Having done that, I've now got my rows in my in-memory version of the CSV file. I manipulate it. I need to work out, okay, well, this column timestamp is going to be my observed at. This column value is going to be my value for my device. This quality is going to be metadata of my device, and so on and so forth. Then you get this to convert to an NGSI format, and finally you send upserts. Having done that, when it doesn't work, you need to understand it. So you're going to retrieve responses from the context broker to work out, is this data has this data successfully been received by the context broker? Were there errors? What do I need to do on errors? This particular process will be working using the NGS ILD format. So we have a custom IoT agent, CSV agent, and Mongo database. You can see I have here just a simple Docker file, using a Docker file. It's very, very simple. You've got the Docker file is just I'm listening on a 3000 endpoint Alpine application. It just runs something. So I'm just listening on a port of some sort. I have an Excel file which is somewhere. I can then send that to the system if it's running. And it takes some time to load up, and it has successfully loaded some data into the system. I can then upload a CSV file. If you have a look at the CSV file, it's just a load of headers, as you'd expect, with data in them, which again, these NAs I need to get rid of when I'm looking at my data. So I can just load my CSV file. And it's taking a bit of time to load up because for various reasons. Firstly, it needs to get hold of the context file. Secondly, this is actually doing a batch update. So it does take a bit of time to upload information, if it's particularly when it's running for the first time. And then once it's successfully updated 1,000 lines or whatever, it will actually get hold of the information. Let's see what the code is doing whilst it's processing. So once again, I just have two endpoints. I'm just loading up a file. I just need to upload the file, and then asynchronously, I'm going to run over that data and do my upsert. If I look at my controllers, these two are very similar. There is a series of actions you do through the upsert. You read the file. You read the file. You then create entities from that file. I can then delete that file. I can then do the actual upsert measure. As you can see, all this has been placed into promises so that I can upload multiple files at once. And when I get hold of the file, I can say, okay, I can remove the header file. I can get hold of each attribute is going to be a value. It's going to be an entity type device. It can be URN device, blah, blah, blah. And then I can add in based on, is it a float? Is it an integer? Is it a whatever? Because this will depend on my values, I'll put that into a config file saying these attributes are floats, these attributes are whatever. And I can then push the data up into the system. For the actual push, it is just a simple upsert function. All you've got is a simple upsert function. Say yes, I'm sending my my linked data with a necessary header, and I have a function to send. Having done that for my Excel, I then catch any errors and send any errors as necessary coming through the system. CSV is just the same. It's the same sort of thing. Again, I've got a load of custom constants in here which I need to be able to deal with, and I want to be able to deal with metadata or what have you. I just read in the CSV file. I just read in the CSV file using standard file streaming. Not a problem. I can then pipe it to get hold of data. I can extract information, because all this will be custom. This is not something which you're going to be able to copy straight off, but you just need to be able to see what happens. Once again, I have my upload function is the core of what it is. You can see that I've got my sanity check. It's not a CSV file or whatever. I can then just read the rows, create measures from the rows, because I'm getting hold of data. In this particular case, I need to get some data from a database as well. But that's within the asynchronous data. So we wait until all my database requests and what have you have actually run before I push my data into the system. So that is a method of attacking a file-based system. All of this is, of course, available online. In summary, where possible, don't write your own code. Where possible, reuse and extend what's already there. What you gain from that is that you don't need any of this error handling type stuff for my upsert or being able to do NGSI operations. You'll get all this straight away. It's just in there. And if you can get to a format which is understandable by an existing IoT agent. So let's say you want a gateway which has almost got the JSON format. You could have a gateway listening on MQTT, listening to some proprietary JSON format. It could say, oh, I've got a message, let's push it up the context broker. It does the work, and it's just another middleware. But if you need to write it, you can be pretty certain that the existing IoT agents work. They will have extensive unit tests. They're actually in commercial production. So you can just pick up the open source code. It's usually AGPL. And indeed, you could even, if you want to make changes to one of the existing ones, you can obviously raise a PR on it. And then just work out what you need to do, considering these three layers: the payload, the transport, and the protocols. Now, the alternative, just pushing data straight in, as you can see, it's really a matter of going through those 7 steps. You just read the various different elements, and it's a matter of reading in, manipulating, and then doing an upsert. In many cases, you won't be interested in actuation in that particular case. I'm just being giving a file or whatever. I know this has been a quick run through. Therefore, all of this code is available: the custom IoT agent, the ISOXML agent, and the load up to CSV, so you can run all this stuff yourself. And of course, there's a lot more information on the existing IoT agents within the FIWARE catalog. And of course, beyond the custom IoT agent, there are many other tutorials to help you with other elements. So that, in summary, is how you would extend your system to use a custom IoT agent, because it is necessary in certain circumstances. And all that it remains for me today is say, I hope you've learned something, and I hope you enjoy the rest of your day. Thank you very much.